Welcome, and thanks for joining this overview of AI agent architecture. In this presentation, we will walk through the key components, how they interact, and why they matter for automation and decision-making across industries. Think of this as a practical guide to what makes intelligent agents function effectively in real-world systems. In simple terms, an AI agent is an autonomous system that perceives its environment and takes actions to meet goals. There are different types, from reactive to deliberative and hybrid agents, each suited to particular tasks. Across healthcare, finance, and customer service, these agents automate work, speed decisions, and improve user experiences. This slide breaks down the three core modules that make an AI agent work together: perception to gather inputs, decision-making to evaluate options, and action to execute outcomes. Visual elements here help show how data flows between modules, illustrating that robust architecture depends on seamless integration and clear interfaces. The perception module is the agent's senses, combining sensors and data collection with signal processing to turn raw inputs into usable information. It also supports real-time interpretation so the agent can react appropriately to changing conditions, and it lays the foundation for accurate downstream decisions and actions. The decision-making module is where information becomes choice. Algorithms and models analyze perceived data, guided by machine learning to spot patterns and predict outcomes. This module must account for internal and external factors, including bias and uncertainty, to select the most appropriate action under predefined criteria. The action module translates decisions into real-world effects by executing commands, managing interactions with external systems, and adapting based on feedback. It relies on reliable execution processes and continuous monitoring to ensure tasks complete effectively, while feedback loops help refine future behavior and improve responsiveness. Communication is central to intelligent behavior. Natural language processing enables human-like interaction, while multi-agent communication allows different AI systems to coordinate. Standardized protocols ensure interoperability, so agents can share data and work toward common goals securely and consistently across platforms and deployments. Learning allows agents to improve over time through methods like supervised, unsupervised, and reinforcement learning. Agents can adapt via evolutionary strategies and continuous learning techniques that update behavior from new data streams, enabling them to handle complex, changing environments without retraining from scratch. Developing AI agents brings challenges such as technical limits in complex reasoning, ethical concerns around bias and accountability, and security risks from cyber threats. Addressing these requires careful design, rigorous testing, and strong governance to ensure agents are effective, fair, and protected against misuse. Looking ahead, advances in algorithms, tighter integration with IoT devices, and emerging computing paradigms like quantum processing will reshape agent capabilities. These trends promise smarter, faster decision-making and novel applications, but also demand updated tools, standards, and ethical frameworks for safe deployment. This slide presents real-world examples where AI agents deliver value, from healthcare diagnostics and patient management to autonomous vehicle navigation and customer service automation. Each case shows how agents can enhance accuracy, safety, and user satisfaction, while highlighting practical constraints and lessons learned from deployment. Designing an AI agent starts with defining clear objectives, collecting relevant data, choosing models and tools, and following a structured implementation plan. The right frameworks and technologies speed development, while careful testing and validation reduce risk and ensure the system meets performance and safety expectations before launch. Evaluating agent performance depends on measurable metrics and benchmarks that reflect reliability, efficiency, and user impact. Combining quantitative assessments with detailed case study analyses helps identify strengths and weaknesses in real settings, guiding iterative improvements and aligning outcomes with stakeholder expectations. Ethical considerations must be built into agent design, focusing on fairness, privacy, transparency, and accountability. Addressing bias, safeguarding user data, and explaining decisions fosters trust and helps organizations meet legal and social responsibilities while reducing harms associated with automated decision-making. AI agents are most powerful when they augment human capabilities rather than replace them. Collaboration brings together human intuition and AI speed, producing solutions neither could achieve alone. With the right workflows, agents free people to focus on creative, strategic tasks while handling routine, data-driven work. The regulatory landscape is evolving to govern safe and ethical AI deployment, with existing frameworks guiding responsible development and anticipated policy changes responding to new risks. International perspectives show different approaches, so keeping abreast of regulations is essential for compliant, scalable AI agent projects. Building trust is foundational for adoption. Developers should prioritize transparency, understandable explanations, and mechanisms for user feedback. Trustworthiness influences satisfaction and long-term use, so practical strategies include clear communication about capabilities, robust privacy protections, and easy ways for users to challenge or correct outcomes. Interactive agents like chatbots, game AI, and social robots demonstrate how design choices shape user engagement. Chat interfaces enable task support, game agents create dynamic experiences, and social robots offer emotional cues and companionship, each requiring careful tuning to user needs and context. In business contexts, agents automate repetitive tasks, generate actionable data insights, and enable more personalized customer engagement. By streamlining operations and informing strategy with predictive analytics, AI agents can boost productivity and competitive advantage while freeing teams to focus on higher value initiatives. In entertainment, AI enhances gameplay with adaptive behavior and dynamic worlds, assists film production through creative tools and visual effects, and enables interactive storytelling where user choices shape narrative outcomes. These applications highlight how agents can expand creative possibilities and audience engagement. In education, AI supports personalized learning paths, provides real-time tutoring and feedback, and uses gamification to boost motivation and retention. By tailoring pace and content to individual needs, agents help learners stay engaged and achieve better outcomes, while teachers gain tools to scale personalized support. In smart homes, AI agents coordinate home automation, strengthen security with continuous monitoring, and optimize energy use through intelligent management. These capabilities deliver convenience, safety, and efficiency, but they also require careful attention to privacy and interoperability across devices and platforms. Interface design for AI agents should focus on intuitive user experience, clear visual principles, and accessibility to ensure all users, including those with disabilities, can interact effectively. A thoughtful interface communicates functionality, builds confidence, and reduces friction in everyday interactions with intelligent systems. Interdisciplinary approaches bring psychology, neuroscience, and cognitive science into AI development to create more natural, effective agents. Understanding human behavior and cognition helps improve interaction design, learning algorithms, and problem-solving techniques, ultimately producing systems that align better with human needs and expectations. The societal impact of AI agents spans cultural shifts, changes in employment, and evolving consumer behavior. While automation can displace certain jobs, it also creates new opportunities. Assessing social implications helps guide policies that support workforce transitions and equitable access to benefits. Open-source communities accelerate AI innovation through collaborative development models and freely available tools. These networks foster knowledge sharing, reduce duplication of effort, and enable wider participation in building and improving AI agents, which can speed adoption and diversify contributions across the ecosystem. Regular maintenance and updates keep AI agents secure, performant, and aligned with user needs. Implementing systematic checkups, monitoring for drift, and integrating user feedback ensure agents remain reliable, address emerging issues, and continue to improve over time without full retraining from scratch. Research on AI agents is expanding into new areas, blending disciplines and exploring how public and private investment shapes progress. Emerging studies focus on advanced learning techniques, responsible design, and interdisciplinary collaboration, all aimed at developing agents that are more capable, ethical, and socially aware. To conclude, AI agents are evolving rapidly and offer transformative benefits across sectors, but realizing that potential requires ongoing innovation, thoughtful governance, and multi-stakeholder collaboration. By balancing technical progress with ethical responsibility, we can unlock value while managing risks and ensuring inclusive outcomes. This final slide opens the floor for questions and discussion, inviting participants to raise clarifying points or suggest future topics. Use this time to surface concerns, highlight key takeaways, and propose next steps so we can continue the conversation and translate insights into practical actions moving forward.